Hi, so I'm going to record one of the problems from the previous homeworks about phase diagrams. I've already kind of marked this up a little bit. So there's a few different places you can start. You can either look at the pure forms of A and B, you can look at this compound that forms between them, or you can start looking at these eutectic and peritectic reactions. So I'm going to start with the compound, just get it out of the way. So we have the mole fraction of A to B, and we need to get the weight percent. So that'll end up being, we're going to use the stoichiometric ratios. So if we have 3 times the weight of B, it'll be that divided by 3 weight B plus 2 weight A. And then we have the A is, weight of A, sorry, is B over 2. So when you take that all together, it'll end up being 3/4. So we can go ahead and mark that. The other thing we know about this is it melts at 1230 Celsius. So let's see, let's mark up, I'll call this 75%, 3/4, 50%, and 25%. Okay, so this one, we'll go ahead and draw it in. There you go, 75%, and all the way up to, what did I just say the temperature was? 1230. 1230. Okay. This to be straight. All right, there we go. So this is our A to B3. All right, so we've done the first part, and what it also tells us, so far this is a compound that would be insoluble, but it does have some solubility for A, so we're going to have epsilon over here somewhere. We don't know where yet. All right, so that was the first step. The next thing I'm going to do is start filling in the eutectic and all of these reactions. So like I said in the previous video, the way to think about it basically is eutectic will be the bunny ears up, and same thing for eutectoid, and peritectic will be bunny ears down. U dash and then peri dash. So what we're going to do for each of these is each one gives us 3 points. So for example, 1000 degrees Celsius. So 1000 degrees Celsius, we have 55% B, 25% B, and 60% B. I don't really care what the phases are yet. It's just, we just gotta start filling in the points. So 1000, so 1000, we have 55, 25, and what was the last one? 60. Okay, so we can go ahead and fill that in. And so that's a eutectic reaction. So we know that it's going to be bunny ears up from this middle point. We don't know how it connects yet, but it'll be something like that. Okay, so now we do the next one. At 650 Celsius. I'm going to leave that one off for now. Peritectic. We have at 1300 Celsius, we have 8% B, 35% B, and 15% B. So, oh my God, I just forgot that already. So 600 Celsius. We're going to have an 8% B, so somewhere in here. And then 25 and 30, 8, 15, 35. Okay. 8, 15, and 35, somewhere in here. And that's at around 600 Celsius. Or, oh, I got thrown off. Or that one's at 1300. Oops, sorry. Move it up to 1300. Now it's the one that's actually at 600. Oh, and that one, by the way, is peritectic, so we're going to draw it downwards. It'll be something like this. Okay, and now we have the eutectoid one at 600 Celsius, the one I sort of crossed over with. And so that one we have 12%, 5%, 65%. So we'll put in the 5%, 600 Celsius. 12%, is that right? Yeah. And 65% out here. So we can go ahead and connect that. And that one was eutectoid, so it'll probably go up. And then finally, peritectoid. Okay, these two are both on the far side, I think. So we'll go ahead and fill those in too. So at 650 Celsius, we're going to have 90%, then these two compounds. So we'll say pure B is out here. So 100. 100%. And are you 90%, 75, 100 at 650 Celsius. 650. So 90% would be about here. 75 implicitly, and then 100. Okay. And that one, make that straight. So that one is eutectic. So we'll go ahead. And this one, we're going to be able to start connecting them soon. Let me draw the last one first. Let's see, which one was it? This peritectoid one. At 300 Celsius, we have alpha 3%, 69%, and 40%. Okay. So 40%, 69%, somewhere in here, and 3%. That's fine, whatever. Draw them out here. And that one, peritectic, right? Yes, I'm just realizing now I didn't leave much room for myself at the bottom. So the other thing we can start to do now, okay, we can start filling in all of these actual phases. So we have that the delta phase is from 35% to 45% B. So we can fill it in right here. I'll call this 35 and this 45. And this isn't going to be the scale at all because I did not scale this well, but that's delta phase. Okay, and so then this is our peritectic point. Great. And then on the left-hand side, we have all the pure phases of A. So it says it has alpha, beta, gamma from the bottom to the top at 800, 1150, and 1980. So we have 800 here, 1150, and 1980. And so this will be we can connect this up, I believe, right here. So, and we'll do this too right there. Alpha, something like that. Alpha, and then this one up here will be our beta phase once we fill it in, and then we'll have a gamma phase, or yeah, gamma phase up here, right? Yes. Okay, I'll put in the gamma too. All right. Let's go ahead and start connecting these up. So this one here, this will be alpha plus beta. And this, so let's look at that eutectic point. So that's the 1000 Celsius. Or wait, is it? It's the 600 Celsius. It's this one, the eutectoid one. So beta, alpha, epsilon. So beta over here, we can go ahead and connect this. Alpha, and so this will be beta plus epsilon. We can also close this off. So this region right here will be beta plus epsilon. And then let's go up to the next one. So this one at around 1000, that's also eutectic. So that one is liquid, then beta plus epsilon. So what that lets us do, let's see, we're gonna want to connect you, I think, and you. I'm gonna erase this one, so this is the actual thing. Then we're gonna have liquid up here. So down here it should be beta plus epsilon. This one will be liquid plus epsilon, and down here we should have like a beta plus liquid, something like that. Okay, I'm gonna erase that, move that back. And so I'll go ahead and connect these. Sorry if this is a little bit rough. That's just the only way to do this problem. Go step by step, and then check them all at the end. So let's see. We have peritectic at 1300 from gamma to beta plus a liquid. So that should go down here. And then the we would have over here that B. So this is beta now. And that makes it peritectic. So this will be beta plus liquid. We have the gamma still to go. I think it would be, so this should be pure gamma. And then we'll have a gamma plus liquid right here. And then we need a region right here too. So that'll be a beta plus gamma region. Let me move my gamma a bit. Okay, gamma. All right, so now we filled all of those in. And so just to reiterate, since I've kind of just been going and not narrating as I go along, you can see the steps we took. We drew the compounds first and the gamma, beta, epsilon, those phases. And then we're going through now and we're taking all of these eutectic, eutectoid, peritectics, and we're using it to fill it in where we're alternating. So we have a phase and then an interphase region, a phase and interphase region. And okay, I think there's still a little bit left to go. Okay. All right. Let's do the ones on the far right side, and also I can fill in this here. Okay. So just to double check all of our reactions over here first, we have, if we have pure A, we would have alpha, which changes form at 800 Celsius to go to beta, and then at a little under 1200, 1150 to go to gamma, and then it melts at 1980 up here, which I realized I drew a little bit high. So that all of those check out. So I'll just go ahead and check these off as I check them. So check, check, check. And then we have the eutectic at 1000 Celsius. It'll go from 55% beta, epsilon. So 1000 Celsius will be this one here. And it's eutectic. Yep, the linears go up. And it has beta and epsilon. And it goes from liquid to, so this is the beta plus epsilon region. This is beta plus liquid, and this is liquid plus epsilon. All right, so that checks out. Now we have this 651. I'll go ahead and fill that one in now. I forgot I didn't do that one. At 650, liquid 90% goes to A2B3. So this is pretty easy to fill in. We have these, and then on the pure B axis, I'll go ahead and draw it as a vertical line. We have the B melts at 800 Celsius. I probably drew that way too tall. Yes. So the melting point of B will be down here at 800 Celsius. A little bit below this. Okay. Oops. 800 Celsius. Okay. All right, that all checks out now. So, and then, so liquid 90% to A2B3, yep. So we can, in this region, we'd have liquid. In this region, we'd have liquid plus A2B3. This region, we'd have liquid plus B. And then we go down and we have A2B3 plus B in this region right here. Okay, so we'll go ahead and check these two off. Peritectic at 1300. Where are you? Up here. So this is our peritectic point, and it goes from gamma plus liquid to beta. So gamma at 8% should be over here more. That's fine. This is gamma plus liquid to beta. Yes. So go through right here, through the peritectic point, goes from gamma plus liquid to beta. Okay. Good. Am I missing? Beta 15%. Good. Okay, I think that's good. As I see all of the features that I'm looking for, we have, yeah, okay, yeah. We're good. Okay, because we have the three interphase regions. And then finally, eutectoid at 600 Celsius, which is this one right here. And so it has the eutectic character, bunny ears up. And then it goes from beta. On this side, we have alpha plus beta. On this side, we have beta plus epsilon. And then down here, we have alpha plus epsilon, which is what it says. Great. Then finally, peritectoid, 300 Celsius, alpha, epsilon, delta. So we have up here, we have the alpha plus epsilon region, and this down here is alpha plus delta, and this is delta plus epsilon. And then we have the pure delta. So that's our phase diagram. Hopefully that wasn't more confusing than it was helpful. I'll get back to this later.